Good morning to everyone. So today we'll start with the module 1. The module 1 which covers the history of Verilog HDL and the overview of digital design with the Verilog HDL, then hierarchical modeling concepts. So here in this first, let us see, before enter into the history of Verilog HDL, we need to know what is the in the very beginning in the 1983, or I can say normally the digital circuit design has evolved rapidly over last 25 years. The earliest digital circuits were designed with vacuum tubes and transistors, earlier days and all. Later what happened, the integrated circuits were invented, the logic gates were placed on a single chip. So now, if you want to say the history, in the beginning 1983, so the gateway design automation, the company, they only introduced the Verilog HDL. That company, gateway design automation company, later it is given to the cadence design. So what happened later? So it is the main importance of HDL is, so if you want to check or if you want to verify the functionality of the IC before fabricating, so what you have to do in the sense, we need to design a circuit, then that has to be tested by with the help of simulation. So with the help of the simulation, if you want to know what you have to do, we need to write with some coding level. That is why it has come as hardware description language. So here, this simulation environment which has comprises various level of abstractions like switch level or transistors, we can say a gate, register transfer, and higher levels. Now here there are the very three important factors to success of Verilog. What are the three important factors here? I can say the first one is the programming language interface. Sometimes we can call as PLI. What is the meaning of that? The programming language interface in the sense with the hardware description language, that is with the Verilog, you can interface the C language or C++ language. Any language, even the Python programming also can be interface with the Verilog. That is one of the factor here, very important. So we can extend and customize the simulation environment. Any language you can interface with this. Second one is the close attention to the needs of ASIC foundries. So now we need ASIC foundry. We need to know what is meant by ASIC. The ASIC is nothing but a specification, application specific integrated circuit. That is the meaning of ASIC. So ASIC is nothing but application integrated, application specific integrated circuit. This is nothing but a application specific integrated, only we can call it as ASIC. Now what is the meaning of this? Say example, you might have studied in where digital electronics various integrated circuits like logic gates, AND gate, NAT gate, then multiplexer, then for counters. So for this each and every you had one separate IC. That is application specific in the sense that IC is meant for that only. We cannot perform any other operation over there. Say example, nowadays in the market is easily available the microcontroller. It's a single IC chip which has 40 pin microcontroller will be there. That is also I can call as ASIC. It's application specific. So now you are going to develop the integrated circuit for the specific application. That is why I say you may have some thoughts in your mind. So you need to make a separate IC for If you are going for application specific integrated circuit, they are going to fabricate your own IC. If you want to perform like that, automatically what will happen? It will be the cost will be very, very high, because if you are going to produce, or if you are going to fabricate a very limited number of integrated circuit, that is IC, for your own specification, then automatically the cost will be very, very high. If you want to reduce the cost, what you need to do? You need to go for mass production. That is the example we can say the mobile phones we can say. So if you are going for mobile phone production, sir, so if you are like on 10 member mobiles, if you are doing the fabricating or production, if you are making 10 mobile phones, the cost of each mobile phone may become, example, 50,000 example. So, but if you are making like lakhs, 1 million or 2 million mobile phones, and automatically the base price will become as like around 5,000 or 6,000. So that is the reason actually in the ASIC you have to go if you want a more number. That is the reason. But very important, if I go for ASIC, once the IC it has fabricated, then you cannot change anything. The very important thing, before going for fabrication, you need to cross check or you need to verify everything properly, whether it's working properly or not. That is the reason we are going for the coding purpose. So that is why you can say it's a close attention to the needs of ASIC foundation. But you may think only this is the solution, whether if you want to make IC means only you have to go for ASIC. No. What you can do in the sense, that is the reason in our market, additional one more type of logic devices also is available. That is nothing but PLDs. So it is one of the PLDs you might have studied in a logic design. That is programmable logic devices. So even you can go for that PLDs we can say. That is programmable logic devices. Programmable logic devices. Which under the programmable logic device we can say programmable logic array. Programmable logic array, programmable array logic, and FPGA. The FPGA stands for FPGA. That stands for Field Programmable Gate Array. Then another one more also is there, that is called as CPLD. That is Complex Programmable Logic Device. See, these are the PLDs are available in the market, either FPGA or CPLD. You can. So it is here ready-madely available ICs. So in that, what you can do, you can dump your programs in this device. Example, I'll take it FPGA. The FPGA is ready-madely available in the market. What you can do, it is pre-defined everything internally. You are writing the program and you need to download into the FPGA. In our lab, we are having FPGA device. Example, which device we are having in the friends? We are having Spartan 6 device. We are having Spartan 6. In this, so many variety of devices is there. The next is Spartan 2, Spartan 3, Spartan 6. The next is family called as Vertex. One more devices I can call as Vertex. This is also one more. It is for high-end applications and all they will use the Vertex and all. Nowadays they are using in the remote sensing area, their places and all. They are using the Vertex only. Even though in your now recent in the electronic components and all, they are using Vertex device like to check. That is what they are doing. Now, what you can do in the sense, very simple, I can say, you are right, you assume you are going to design here one microcontroller. So that microcontroller, you might have drawn the microcontroller complete architecture. You remember you studied microcontroller subjects. So the complete microcontroller architecture is there. So how you will write the program? Each and every module you need to write the program separately. Then later what you need to do, all the modules should be integrated. Then that should be downloaded into the FPGA. After that, that particular FPGA will act as microcontroller. If you are downloading the counter to the FPGA, then that FPGA will act as counter. So it is like this, you can erase the program, you can do. It is not like one-time programming. You can erase it and then again you can reprogrammable. That is the very important feature of FPGAs. You can reconfigure the architecture. That is very important in FPGA. You can do the reconfiguration. Next thing is, it's a very important thing. The factor is the Verilog based synthesis technology. The very important thing. What is meant by the synthesis here? This here, the synthesis is nothing but what is the synthesis? See here, I will say the synthesis. What is the meaning of synthesis? The synthesis is nothing but it will convert from the software to hardware level inbuilt in the tool. Later we'll see what is that. So example, the gateway design automation is licensed Verilog to Synopsys. You may think, what is the Synopsys? Synopsys is a company. It is a EDA based company. Synopsys is a EDA based company. So which is company is available in Bangalore also. You can see actually. The one more company is nothing but the Cadence. The one more company is Cadence. So it's EDA company list. Synopsys, then Cadence, then Mentor Graphics, then Xilinx. So these are all the some of the companies which are giving. These are some companies. It's a EDA tool. They are the people. Now it's audible. Now it's audible.
Yes, sir.
Yes. Okay, so from where actually it has audio breaking is got? From which portion? From the beginning? I got some of them has got voice breaking actually. From there actually. I think now it is audible, right? So the three factors of success. These are the three factors of success for interfacing C language, Python language, Java, any language you can interface Verilog environment. Then we can have the close attention to the needs of ASIC foundries. Here you may think one more thing I want to say, foundries they said, right? Who wants the foundries? Foundries means the manufacturer of IC. That is the technology based. Who and all the manufacturer? So that we want to say, right? The foundries, example foundries, I can say TSMC, Taiwan Semiconductor Manufacturing Corporation, that is TSMC. Then global foundries. These are the foundries we are having actually, global foundries. So these are some very popular foundries, I can say. Very popular foundries, TSMC, global foundries. Even some other foundries also is there. So these are the people will fabricate, or I can say they are having the fabrication, like they give the technology, the silicon wafer production they will do. So now the gateway design automation, they are partnered with the Motorola National and UTMC in 1987-18 as the world. Later, this gateway automation only brought by Cadence actually. Cadence. This is gateway design automation, GDA. I can say as GDA. Cadence bought the GDA. Now presently this company is available in Bangalore. Next, the Verilog based synthesis technology. The Verilog HDL language is based on the synthesis technology. You can synthesize it. You can check that gateway design automation. It's licensed Verilog to Synopsys. The synopsis introduced the synthesis from Verilog in 1987. Even though the cadence also introduced the synthesis, here they highlighted only the synopsis. But don't think why only synopsis. But in our academic institutes, we are not using the synopsis tool. The reason was it is quite expensive compared to the cadence design. In our lab, we are having cadence tool actually. Next, the history of Verilog we continue with. As I said, we are having two different types of HDL language. The which one is Verilog HDL. Second one is VHDL. Already we said the VHDL is the one more language. It is the VHDL. The expansion is VHSIC. That is VHSIC hardware description language. So the VHSIC can be extended as very high speed integrated circuit hardware description language, that is HDL. So the VHDL is nothing but I can say VHSIC HDL can be expressed. So it is developed under the contract from PARPA, that is nothing but you can say defense actually. The initially VHL only was developed, later only the Verilog has come. So that is initially they used in the US defense military purpose actually, it is not for commercial purpose. Later what happened that VHL they got as IEEE standards. Any electronics in the world, if it is standard by IEEE, then it can be recognized or can be used globally. That is the main important the standards, the IEEE standards. You might have seen in your communication, the wireless communications and all. I think you studied or you are going to study computer communication network. In that you will have IEEE 801 or you might have seen somewhere IEEE 801.1111 or 801.33. So like this some numbers will be there. These are the IEEE standard for various communications can be used. So now once we get the IEEE standard, then it can be used for public domain. That is why I said globally, it's commercially we can use. Now other EDA vendors adapted VHDL. EDA means electronic design automation. That is EDA. The expansion for EDA is electronic design automation. That is why sometimes they may call EDA tool. EDA tool only, as I said, cadence, synopsis, Xilinx, mental graphics, all are called as EDA tool. So electronic design automation tool, they may call. Electronic design automation called. Other EDA vendors adapted these companies. Which are the companies I said? The companies are already, as I said, synopsis, cadence, mental graphics, then Xilinx, etc. These are the companies that adapted the VHL languages actually. Now, Gigatia put Verilog in the public domain during the year of 1987 itself. Now, today, the market is divided between Verilog and VHDL. This is what already we know. The market divided, that is VHDL mostly used in European countries. The Verilog is dominant in the US country actually. So this already we discussed VHSC Verilog. The Verilog very important. The VHDL is a more generalized language. It not all constructs are synthesizable in the sense in VHDL we will study later. We are not going to study the VHDL language actually. We are going to study only the Verilog. But here we can say some of the constructs are not synthesizable in the VHDL, but is possible in the Verilog actually, but not as general as VHDL or Verilog actually. So one more thing is, as I said earlier, the VHDL is a not case sensitive, very important, but the Verilog is case sensitive. Next thing is I can say here it is easy to learn. This one easy to learn, more data types actually it has, more data types. Then what other things are having? More data types it has. Then it has library is available here. Packages are available. Packages. But if I see here, less data types, it is easy to learn. Easy to learn. Then library, no library, that is library is not available. Then no package, no packages. These are the some difference between VHDL and Verilog actually. Overview of digital design using Verilog. Now let us see the overview of digital design in the Verilog. In this we are going to study the evolution of computer aided design. Digital design, how the computer aided, that is CAD tool will play a very important role, how it evolves. Then the emergence of HDL, then some of the typical design flow cycle we are going to see. Then what is the importance of HDL and why the Verilog HDL is popular, then what are the trends in HDLs? Those things we are going to see here. Now, evaluation of computer aided digital design. Now, in this, we can say evaluation in the sense simple. I can say, you see this tabular column, the evaluation, how the evaluation IC era has come from the beginning. During the year 1947, what happened in the technology? The invention of transistors happened during 1947. So at that time, during only the transistor was informed, so like only single transistor. With the help of this transistor only, we can go with the product. But with the help of only the transistor, we cannot design any circuit. Example, if you want to say, you can take BJT transistor. With the help of only BJT, you cannot perform anything. What you need, you must to use something like any other additional components required. Later, during 1950s, between the 1961, the discrete component has come. That also will like one quantity is the approximate number of transistors per chip in commercial product here. This one all is showing only one. The typical product here. What is the product we are having? It's a junction transistor and diodes. The junction transistor in the sense, I can say UJT, or sometime I can call it as the MOSFETs and the diodes. The diodes in the sense, not only the PN junction diode, they can have the silicon control rectifier, SCR, and UJT, anything, all the diodes, Zener diode, we can have here. But later, what happened during 1961 to 1966, initially it has come as SSI. SSI is nothing but small scale integration. The small scale integration in the sense, how many transistors will be there per chip? Totally 10 chips, in the sense 1 to 10. So we can take like this, from 1 to 10 chips, transistors are there in a single IC, that I can call it as small, that is a small scale integration. So what are the typical products will be there? That is a planar devices, the logic gates and the flip-flops. Those things will come under SSI. Next evaluation is, you got as MSI. MSI is nothing but medium scale integration, we can say. Medium scale in the sense, we can say it is between 10 to 100. So SSI is 10 to 100, I can say. Okay, SSI is 10 to 100. The medium scale is 100 to 1000 transistor will be in single IC. You think single IC, the transistors are from 100 to 1000. So the example for MSI, I can say multiplexers, counters, adders. These are the examples for MSI. Large scale integration, that is nothing but LSI. So in the LSI, the number of transistors between 1000 to 20,000 will be available in a single IC. So the example for large scale integration, I can say 8-bit microprocessor, that is the memories also we can say, that is the ROM, RAM. So this and all will come under large scale integration. Later only we got as VLSI, that is very large scale integration. That is what we are having 20,000 to 10 lakh transistors will be available in a single IC, or it is integrated in all 20 to 10 lakh transistors are integrated in this chip. Those many chips are available. The examples of VLSI, I can say 16-bit and 32-bit microprocessors and some sophisticated peripherals, GSM, DRAM also I can say. The example. Those things and all will come in the VLSI. Later, the ULSI has come. The ULSI is nothing but it is a 10,000 or it's a 10 lakh transistors to 100 lakh transistor will be in a single IC. The examples are the special processors. The special processor, the sense you know that which is a special processor. Example DSP. Example you can take DSP processor. We can say here. You can consider this DSP processor. That is a special processor. Then virtual reality machine. That is we are nowadays we are using, right? AR, augmented reality, virtual reality. Then the smart sensors. What are the smart sensors we are having nowadays? Like example, proximity sensors. Then some of the sensors will be there. Those things and will come under USA because the sensor is very small, tiny, small element. But we can say it has number of transistors are like this. So you may small like this only will be there, but the number of transistors will be how much? See, these many transistors will be available. You have to think now. The earlier here you can see in SSI, your IC was the size is this in SSI. Then MSI, the IC sizes become as like this. Then LSI, the IC sizes become as like this. Then VLSI is become as like this in the sense. Then ULSI will become as like this. Now you can think in this only 10, but you can see here the size is reduced, but the number is increased. Still the size is reduced, the number is increased. So what happened? The size of the transistors get reduces keep on. So later the GSI is a giant scale integration. It is greater than 100 lakh transistor. Still it is not under production reason. Still we didn't get any products under the GSI. So this is nothing but I can see the evolution of evolution of IC era. We can call it this is IC era. Sometimes we may call it this is how the IC has come. Emergence of HDL. For a long time, actually programming languages such as in the olden case, the Fortran, Pascal and the C were being used to describe the computer program. But that was sequential in nature. Similarly, in digital design field, the designers felt to need for a standard language to describe the digital circuits. So the hardware language, that is the HDL, came into the existence. So now in this, if you want to use the HDL, it allows the designers to model the concurrency of process found in hardware elements. The hardware HDL is such as VHDL and Verilog HDL. But with the help of the VHDL and the Verilog, only with the Verilog, we cannot do anything. We need some simulators also. That is, the simulators is emerged here. So in this later, what happened? The usage will be, what is the usage of simulation? As you know, you might have used some simulation in the earlier times and all. What is the purpose of simulation? The simulation is nothing but checking the functionality, or I can say functionality verification, I can say. That is the usage of the simulation. So why we need simulate? The simulation we can cross check whichever the circuit we design, that we can cross check whether it is giving the or its response to our given input. For that purpose only we need a simulators. So at the same time it can be the path to implementation also. So like it's a manual translation to gates also is available, or we can do like manual translation to gates in the sense you can write the program, you doesn't know how the circuit diagram will be. So but you think you might have wrote the program in the earlier case and all. Example, if you want to say you earlier we wrote like this A and B. If I written like this, the system can understand this is the AND gate. But you should think if I use if A is equal to 1, then Y is equal to B, Example I am saying, simple example, y is equal to b, else y equal to a. If I write the program like this, what the system can understand, what kind of the circuit the system will generate. That is very, very important. You may think, right? So the system will think in one way and it will generate the gates for your if statement or for statement or case statement. Later we will see these things and all. The logic synthesis technology in late 1980s, we use the synthesis technology. So this synthesis and all we will see properly in the next class. Is there any doubt still now actually? This is all about today's class. We'll catch you in the next class. Still so many people are not submitted your assignments. You must to submit your assignments on time, which I sent in the Google class.